class. Okay, so a scalar is a measurement that has just magnitude. Magnitude is how much, the number or the amount. Some examples of scalar: mass, temperature. Example of a vector is a measurement that has both magnitude and direction. So it's how much and in which direction. Okay, so our first introduction to a measurement would be position. This is where you are at, okay? Your location, okay? It's usually given from a reference point or like an origin. So on our football lab, we would say the end zone was our 0 position. In this class, we like the metric system, so any kind of length distance is going to be, the default is meters with a symbol of lowercase m. Okay, so person B, sorry, A has a location of -4 meters from relative to our 0. Person B has a location or a position of +7 meters. Good with that? It's like where you're at. Displacement. This is change in position. Another way to describe this is how far and which direction you are from your starting point. Okay. How far and which way? Sorry. How far and which way you are from your starting point. Okay. We'll talk about how to solve that in a little bit. Do that. So distance and displacement. So distance, this is a scalar. This just says, communicates how far. The magnitude is how far. Displacement, this is a vector. And it communicates how far and which way. It communicates both magnitude and direction. So which of these two measurements communicates more information? Displacement. So which of these two measurements do you think we're going to tend to go with in physics? Probably displacement. It has more information there. Okay, not only does it tell us which way, but it also tells us, sorry, how far. It also tells us which way. Okay. All right, in math class, how did you figure out how fast you're going? What's your speed? How do you calculate that? Shout it out. Distance over time. Speed is equal to distance over time. Okay. Possible units for speed, shout them out. miles per hour, meters per second, anything like that. Kilometers an hour. Okay. Like speed, how fast you are going. Nothing too crazy there. Good with that. All right. So velocity. Might have heard of that before. The variable for velocity, the symbol that we use is a lowercase v. In algebra class, when we're solving for stuff, the default is an x, right? Solve for x. In physics or in science in general, usually a variable represents a specific measurement. Okay. So if you're trying to solve for velocity, don't put x, put a lowercase v. Okay. The average velocity is equal to displacement over time interval. Is equal to displacement over time. Textbook definition is the rate at which position is changing. The rate at which position is changing. Good there. We'll talk about that later. Okay, speed and velocity. Definitely some similarities, but what are the differences? Speed is a scalar, and it talks about how fast. Velocity is a vector, and it talks about how fast and which way. So it communicates direction as well. Which of those two do you think we're going to go with? Usually, probably velocity. It's a richer measurement. Communicates more. All right. So that would have been your pre-reading stuff, your pre-quiz. We would have taken, like, we would have gotten all that out of the way. Okay. So by the end of this lesson, you'll be able to know the differences and similarities between displacement and distance, describe another way to communicate ratios, know the difference and similarities between velocity and speed, and be able to calculate the average velocity for a trip in multiple parts. Okay? That's what you should be able to do by the end of tomorrow. Okay? All right. Chemistry review. What is the variable or symbol for change in? Finley. Yep, a triangle, delta. Remember that? Delta, change in. Okay? How do you find the change in anything? Mathematically, what do you do? I know you know this. Yep, subtraction. What are we subtracting? So close. There it is. Final minus, instead of original, I'm going to say initial. Okay? That, if you flip that, would that be the same? Initial minus final, is that the same thing as final minus initial? No. Okay? There's only a few things I'm going to tell you to memorize. This is one of them. Change in is always final minus initial. How should you remember that? Maybe think alphabetical. Okay. Do that. Final minus initial. All right. The variable for position, variable for velocity was a lowercase v. The variable for position is x. That's kind of nice. We're used to x. X is like comfort zone. Oh, I like solving for x. Okay, that's for position. That's very specific. The variable for displacement. So we said that displacement was the change in position, right? So how do you think we'd write that? Yep. There it is. Delta x is displacement. And the equation for displacement is going to be, how would we solve for it? Delta x is equal to, you got this, I know you do. You're like, oh yeah, I knew that. Yeah. There it is. Final position minus initial position. Okay, these little subscripts, this one stands for final. You don't stick another number in there. They're just little name tags. Help describe stuff. Okay, so final position minus initial position. The unit for displacement is in meters. That's the default. Doesn't have to be, but that's our default in this class, in meters. Okay, who is tired of me talking? Now, these next couple slides, I'm going to be posing questions to you. This is largely what lecture looks like, me just throwing questions out at you. Okay, here's how I want you to engage in this. When I first put the question, I want you to think of the answer. I want you to make your best guess. Okay, I don't want you to confer or have converse with anybody. I think what you get, I don't know. Okay, that comes later. I just want you to have a mental conversation with yourself. Okay, best guess scenario. Kind of pretend like it's a test. Can't really, hey, what'd you get? That's cheating. Okay, I need you to like think on your own 2 feet, best guess, and then once everybody, I feel like everybody's had a chance to come to a conclusion, then I will say, find someone to talk with. At that point in time, you're going to say, hey, I got A. What'd you get? Oh, you got B? Why'd you say B? Like, I said A because of this and this and this. I think you're wrong. I think A is right. Well, you said, and that's when you have a conversation. Sound good? Thumbs up when you have a guess. Have a conversation with people around you. If you see someone who like is left out, bring them into your conversation. You got a shaky one. Correct answer is, what do you think? What's your guess? Ah, all right. So flipping back to, I know I didn't write these down, but definition of magnitude: the amount, the number, how much. Okay. So for this, the amount, how much, would be 40 meters. Okay. The direction would be communicated how? The negative. Okay. So the magnitude, anytime it says magnitude, you're simply writing the number down and the unit for the rest of the year. You'll see what's the magnitude that should actually make you happy because it's actually easier because you don't have to worry about direction. Okay. Thumbs up when you have a guess. Have a conversation. Tell them why. Correct answer is, how many people say A? How many people say B? Why B? Doesn't really matter because you're given, what was the final position? 10. What was the initial position? 40. 10 minus 40. So what does the negative communicate? The direction. They're moving this way. You see how that's working? Okay. You see how it's important to make a distinction between initial and final. Okay. Same scenario, but what is the distance? for the sake of time, is everybody okay with A? Okay. Is it possible to have a negative distance? Oh no, I've been taught that's illegal. Okay. Can't have a negative distance. Okay. But can you have a negative displacement? Okay. So in this chapter and the next chapter, we're going to confine our motion to a line. It's one dimension. So you can like do this, you can do this, but you can't get off the line. Okay. So direction, how do we communicate direction? What mathematically is how we communicate direction? Like in the previous example, Cooper. Yes, but mathematically, positive and negative. Okay. The positive negative sign that communicates direction. Okay. Good with that? So we've answered all those other questions already, right? Okay. Displacement's a vector. Can distance be negative? No. Can displacement be negative? Yes. Good? Thumbs up when you have a guess. Have a conversation. Tell them why you think so. Okay, what do you say? Okay, that's I would totally let you like have a great constructive argument, but we're running out of time. Okay, what's our initial position? 20. What's our final position? What's our displacement? 10. Okay. So one thing, so displacement looks at how far you got away from your starting position. Okay, the path taken doesn't matter. Does that make sense? Versus what about the total distance? Same scenario. The distance covered is 50 yards. Does that make sense? Distance communicates how far your feet traveled. The path matter does. Sorry, the path traveled does matter. Okay. Last thing, if you ever run 400, that's like one lap around. Okay. What is your displacement? 0? What? Like I'm exhausted. I'm about to pass out. How can you say my displacement's 0? You started where you stopped. You didn't get anywhere. that make sense? Your distance is 400 meters, but your displacement is 0. Okay. You got a worksheet that's due on Wednesday. You know how to do a third of it, but your notes, this is just me coaching you, should be a dialogue, a journal of what you're learning. We'll pick that up more tomorrow.
Last slide when you said the answer was yeah, 50 yards. How is that?
Because you go from 20 to 50, so that's 30.
Yeah.
And then you go back to the 30. That's another.
Yeah. Okay, that makes sense.
You good with that?
Yes.
We took papers. We did papers like math.
Oh, the pre-test?
Yeah, do you want to mention that?
Yeah. The answer key is online.
Okay.
Grade that. And then tell me what you got out of 20. The format of the answer, I don't care, as long as it's right. So is it a fraction, is it decimal, as long as it's right. Good.
Okay.
So just turn that tomorrow.
Okay.
Thank you.
Mr. Smiley, the next slide with the track. Okay, so I was confused. So, okay, so I run the 400 meters.
Yeah, so you start here.
Yeah.
And where do you finish?
Right there. Oh, okay. That makes sense.
You get to that?
Yeah.
You're welcome.